Now let's take the first question. A random sample of 100 observations produce a mean x bar equals 38.5 and standard deviation x equals 3.2. Find a 95% confidence interval for the population mean mu and then round off your answer to two decimal places. Well, when we read this question, we see that the sample size is 100. The sample size is 100. So n equals to 100. Now, because n is equal to 100, which means that the n is greater than 30, so according to the central limit theory, we can use the z interval. So whenever our n is greater than 30, it's okay for us to use a z interval in the confidence interval problem. Now, because we are going to use z interval, our next thing is to find out if we have um, the raw sample data or we have a summary statistics. In this particular situation, we have the summary statistics. They have summarized the mean and then they've also summarized the standard deviation for us. So why don't we just fill in the necessary information first? So the standard deviation is 3.2. The mean is 38.5, and then the sample size is 100. Now the confidence level, the question wants us to find a 95% confidence level, so the confidence level is 0.95. So now let's go to the calculator to do the problem. So first we go to start, as usual, go to test, and then we scroll to number 7, which is the z interval. Number 7, which is a z interval. So let's press enter. Now once we press enter, then we are going to press enter again to confirm that we do have the summary statistic. Now I have put the information there already. So the sigma happened to be 3.2, the mean happened to be 38.5, the n is 100. We have all the information here. So all we're gonna do is to bring the cursor to calculate and then press enter. When we press enter, it gives us the confidence interval. First we see the lower confidence limit, which is 37.87. They want us to keep two decimal places, so I'm just going to write 87. And then the upper confidence limit is 39.127, which I could just write 0.13 because the question specifically wanted us to indicate to put it in two decimal places. So note, we went to start, we went to test, and then we selected z interval. All right, so that's it for question 1. I just wanted to show you how to use the TI-83, TI-84. So I'm not going to spend time trying to do the interpretation. The emphasis of this video is for you to know how to use a TI-83, 84 to do the problem. All right, so let's take our second question. So in the second question, what we have here, they told us that in a random sample of 16. So first, they've given that the n is 16. Now it means we are leaning towards a t interval, but let's confirm other information. Only the sample standard deviation is given. All right, and finally we are told that the original population is normally distributed. So that satisfies the condition for a t distribution. So we're going to say that we're going to use t interval. We are going to use t interval. All right, now if we are going to use t interval, is it t interval data or t interval stat? Now, in this particular problem, we are going to use t interval stat. Why? Because we have been given the summary statistics. So what is the sample mean? We were told that the sample mean, which is the same as the average we're told is 50, so we put 50 where we will have the x. The standard deviation, we've been told that it is 10. The sample size is 16, and then the confidence level, once again they want us to do a 95% confidence level, so we're going to put 0.95. Remember that confidence level, it's a probability, and because it's a probability, you have to change it into a decimal form. So what should we do? We are going to start, then we're going to select test, then we will select t interval. All right, so let's go ahead and do that. Okay, so start, test. Now t interval should be number 8, I believe. All right, so come to number 8, press enter. It's already showing that the start is pressed, so change the values that you have there. The mean is 50, the standard deviation is 10, the sample size is 16, the confidence level is 0.95, so hit calculate. So then when we hit calculate, it gives us the lower confidence limit and then the upper confidence limit. So what would be our answer? Well, they did not really say we should round anything, so let me write what we have here. So that will be 44.671, and then 55.329. All right, 44.671, 55.329. Sorry. Okay, now let's go to question 3. Now in question 3, what we have here is that the question says arborist is interested in determining the mean diameter of mature white oak trees and takes measurement on 7 randomly selected mature white oak trees. So note here that they're giving us some information about the sample size, which is 7. So our sample size n, it's 7. Okay, now they have also given us the raw sample data. They've given us all the 7 raw sample data. So it also means in this particular situation that we don't have the population standard deviation, so we only have access to, or we will only have access to, the sample standard deviation. Finally, we were also told that the original population, it's normally distributed. So that satisfies all 3 conditions for the t distribution in this case. Well, so in this case, we know we are going to use the t interval. However, we have been given the data, that is the raw data of the sample. We have been given the raw data of the sample. So what do we do? If you are given the raw data of the sample, you have to go to the editor and then put in the information. So we go to start and then edit, and we press enter, and then we're going to put in the information that we have been given. So we have 64.0, then we have 33.4, then we have 45.8, then we have 56, then we have 51.5, then we have 29.2, then we have 63.7. So that is our 7 data. Let's double check and make sure that we have all the information. So our next step is that we are going to start again. Then we select test. Then we select T test, T interval, sorry, T interval, because we are dealing with confidence interval. And then our data is under L1, so we leave L1. Usually L1 is there, you leave it like that. And then the freak list equals 1, also leave it like that. And then so then we select our data and leave freak list like that. However, our confidence interval it's 0.95, so let's put 0.95 over here. So let's go to start, and then we look for test. We still go to number 8, press enter. Now this time around we going to select data because we have the raw sample data. It already have the list as L1 because that is where our data is. Leave the frequency as 1. We already have the 0.95, and then we hit on calculate. So when we hit on calculate, that should be able to give us the necessary information and for the answer. So here we would see that the lower confidence limit is 36.327, and then the upper is 61.845. All right, so that is how we can use the T interval data to find the confidence interval when we haven't given the raw data and the quantity is less than 30. Okay, so let's take the next set of questions. Let's take the next set of questions. All right, so in question 4, what we will note here is that, so let me read the question first and then we will proceed from there. So it says the manager of the diary section of a large supermarket chose a random sample of 250 eggs. So we know our N is 250 eggs cartons, and found that 30 cartons had at least one egg broken. So you would see that there was some inspection that went on, and the investigator was interested in counting particularly the eggs that has at least one broken in it. So for that reason, this also falls under proportion. So what they found out from the 250 is that 30 eggs were 30 30 cartons had at least one egg that was broken. All right, so luckily enough, a lot of proportion question would also give away its keyword proportion. So we also see here that the question is mentioning the word proportion, which confirms to us that this is a proportion question. Because it is a proportion question, we know we're going to use the one prop z int. So we need to put in the information. The x happened to be 30, the n happened to be 250, and then the confidence level. Now this time they want us to do 98, so that will be 0.98. The confidence level will be 0.98. So we are going to start, then test, then we will select one prop z int. All right, so why don't we go and do that? Okay, so let's see. We select start, followed by test. I went too quickly. And then we gonna select one prop z in. Now be careful not to select one prop z test. This is confidence interval, so whatever you select is int. Now usually that you have to scroll down until, if you have the TI-84 plus, you will scroll until you see a. So that's one prop z int, and then press enter. Now it just asks you for the information that we have here. So we need x is 30. So we type in the 30 for x, and then the n happened to be 250, and the confidence level, this time the confidence level happened to be 0.98. So we go to calculate, and then we press calculate. All right, so here we have our answer. We have 0.07219 as our lower confidence limit, and then we have 0.16781 as our upper confidence limit. All right, so that is how to do problems that require us to estimate the population proportion. Now usually when you are asked to estimate the population proportion, it comes in two types of questions. One of it is that they just give you the x value. All right, in this case we were given the x value. The x value is the number of successes. It tells you what the investigator inspected and found out of the data. All right, now what about if they don't give you the x value? All right, so let's check the next question, and that would answer those parts. Okay, so question 5. Now, so in this question, the question says that a recent Gallup poll found that 800 randomly selected drivers surveyed. So 800 random, which is telling us that our n is 800. Our n is 800. And then what did they found? So here they did not give us the x, but in that sample, the p hat, which is the sample proportion, p with a hat, so the sample proportion happened to be 70%. So 70% is 0.70. So in this case, you have not been given the value of x, right? So if you are given p hat instead of x, keep in mind that x is the same as n multiplied by p hat. All right, so if you are given p hat, if you are given p hat and you are not given x, all right, if you're given p hat instead of x, then keep in mind that x is equals to n times p hat. Okay, so how do we go about doing this problem? Now one of the things you could do the multiplication and write it out, and then you round it to the nearest whole number. Another way is that you can just enter the n times the p hat in the x line, and then you can scroll up and round the value. So let's see what we could do here. So we know it is a proportion question because they inspected they went through the survey, and then they found out that 70% of the drivers thought that they were better average drivers. Okay, so let's now see. So the x value here will be the n. We know it's 800. The n is 800. The x will be the n times the p hat, which is the 800 multiplied by zero point 0.7. So that will be 800 multiplied by zero point 0.7. Actually, this is easy to find. So why don't we just go ahead and write it? So that'll be 560. 560. Okay, now that we have it, I will just put the 560 here. I think it's easier just to multiply, round it up to the next, to the nearest whole number, and then you could do it. So our confidence level is 0.95. Okay, so we will go to start, then test, then one prop z int, and then we put in the information. All right, so let's go. Let's find out. Start. Then we go to test. Then we scroll one prop z int. It's usually after the numbers, so that is A. And then let's press enter to select that. Now it says, what is our x value? Our x value happened to be 560. Our n happened to be 800. The confidence level that we are finding is 0.95. And then we hit on calculate. Okay, so when we hit on calculate, we have the following answer. So that is 0.66824, comma, and then 0.73176. So in a nutshell, that is how to use the TI-83, TI-84 calculator function for Z interval, T interval, and one prop Z int. Thank you very, very much.